Dear participants, welcome to our webinar. Please be informed that our webinar is being recorded. My name is Nüket Nur Kılıçkaya. I am International Marketing Leader of Havelsan. It's my great pleasure to be the moderator of this webinar. We really appreciate you finding time to join us today. To begin our webinar, we are pleased to have Havelsan's Business Development Director at Command and Control and Defense Technologies, Mr. Ahmet Altekin, to deliver his welcoming remarks. Dear Altekin, please, the floor is yours, sir.
Thank you, Ms. Nüket. Distinguished participants, it's a great pleasure to host you in the context of Havelsan's Technology Vision webinar series, which I hope you will witness Havelsan's competencies on smart solutions, advanced products, and excellent services. Firstly, I would like to extend my sincere thanks to all of you for your participation in today's webinar on Havelsan Vessel Traffic Services. Havelsan, as one of the leading technology companies of Turkey, offers new generation end-to-end technologies with almost 40 years of experience in the fields of defense, simulation, ICT, homeland, and cybersecurity. As a company dedicated to make the world a safer place through its sophisticated technologies, Havelsan offers its solutions to meet actual safety needs and future security expectations of friendly and allied countries. Dear participants, it's no doubt that naval safety is an indispensable determinant of global safety. For decades, Havelsan has been delivering its reconnaissance, surveillance, detection, recognition, decision support, maritime control capabilities within the systems provided to its customers, inter alia, Naval Forces Commands, Coast Guard Commands, and various ministries. Similarly, Havelsan provides security inspection and traffic services in the seas, coasts, and straits surrounding not only Turkey, but also friendly and allied countries. In this context, today's event on vessel traffic services is so significant that it indicates how naval safety priorities and severities make Havelsan develop critical software and unique systems for marine authorities to manage and monitor vessel traffic in the seas and ports to increase safety and efficiency of naval traffic. Thanks to its high technology products and smart solutions, solid organizational structure, uninterrupted after-sales supports, and focus on high customer satisfaction, Havelsan is your reliable solution partner, which is keen on growing with its customers in a close collaboration. Dear all, before completing my remarks, I wish today's organization will be a very successful one that will strengthen the connections and give rise to new business relations between us. Thank you all.
Mr. Altekin, thank you so much for your remarks. Dear guests, indeed, today's agenda is of great importance. Regarding the VTS domain, thanks to its extensive and comprehensive experience on C4ISR technologies, Havelsan has started its journey in 2013 with coastal surveillance radar system for Turkish Coast Guard Command. And at the beginning of 2018, Havelsan has started to upgrade the Turkish Straits VTS for Directorate General of Coastal Safety. As you all know, Turkish Straits, consisting of Istanbul Strait, Marmara Sea, and Çanakkale Strait, is the only waterway between Black Sea and Aegean Sea, and is very vital not only for Turkey, but also for many countries and economies. Especially Istanbul Strait is the most important natural narrow waterway in the world due to its geographical situation, narrowness, strong currents, sharp bends, uncertain weather conditions, high rate of maritime traffic density, and a large number of vessels carrying hazardous cargo passing every day. Above all, it's more critical that over 15 million people living in Istanbul may face with huge dangers caused by maritime traffic at any moment. As a result, Havelsan VTS was developed using latest technologies and will be operational this year within Turkish Straits. As Havelsan, we are very proud of having a critical role in contributing to enhance the maritime traffic safety and the environmental safety against risks and dangers which may be resulted from maritime traffic. Against this backdrop, today's presentations will incorporate both the technical aspects of Havelsan VTS and its roadmap to e-navigation. Dear participants, during the presentations, You will have the opportunity to submit your text questions at any time by typing into the chat panel. For this, please click on the chat button on the left-hand side of your screens. At the end, we will have a Q&A session to answer your questions. Also, please kindly note that today's presentations will be available on demand. If you'd like to have our presentations, please provide your email addresses either directly to the chat panel or to the contact info I'll be posting to the chat box. Ladies and gentlemen, now we can continue with the presentations of Havelsan VTS team. I'd like to introduce Mr. Mutaz Alkabir, VTS Product Development Team Leader, to start the presentation section of our webinar. Yes, Mr. Alkabir, we are all excited to hear the presentation of our VTS team. Please, the floor is yours.
Hello, everyone. First of all, I want to welcome you to today's session again. My name is Mutaz Alkabir, and I am working at Havelsan as a VTS software product team lead. First, I want to start our presentation, then we will go together on it. Okay. Here is a brief brief summary about Havelsan. It will be included with the presentation, so you'll be able to find it attached with you. Let me start with Havelsan VTS solution. Havelsan VTS solution has been developed with the Turkish Directorate General of Coastal Safety, working with one of the most crowded and dangerous natural waterways for decades. They gained a lot of experience. Working closely with them and developing together shaped our software and give us many, many new features for our roadmap. Havelsan VTS also used the advantage of Havelsan's vast knowledge in surveillance and search and rescue planning and organizing modules to develop a VTS software with top niche technologies. So there is a cycle starting with marine traffic management, safety, navigation efficiency, protection of marine environment, and it goes like this. As our features, Havelsan VTS enables uninterrupted operation from anywhere using web-based technologies. So now we will be talking about Havelsan VTS features. One of the main features of Havelsan VTS is its web-based structure, so it can be used from anywhere. Any operation will be place independent. If you have a laptop with a pair of headphones, even your home will be an operation center. First, beside monitoring and managing marine traffic and ensure control over coastal surveillance, Havelsan VTS help the operation with features like risk analysis, for example, by giving the operator a vast list of conditions that could be combined with each other to form a new condition to alert the operator for risky situations, and others like CPA, TCPA, EBL calculations, ship encounter monitoring, and wait time diagrams. Second, by using Havelsan on-map solution, the map is fully customizable. You will have a full control on S57 or S63 layers, like days, dusk, night settings, traffic modifiers, and view options for the map. Areas, alarms, management also could be customized for the users. Like, for example, with our solution, operators will be able to add as many intelligent areas as they want. Each area has the capability to perform many control conditions that also could be combined together for a safety and control usage. So it will be very, very easy for the operator if he wants to detect a ship with a specific cargo and length and had a problem with authorities and had an air draft more than specific number. Also, alarms for dragging of anchorage ships, or if any ship enters another ship's safety radius, The correlations or change in vessel status could also be monitored from a main alert control screen. SAR and MOB alerts also could be being seen on the map and will not go until actions being taken for safety reasons. Record and replay functionality, also technical and synchronized replay operations, could be also used separately for each recorded data to be exported in desirable granularity. Also, density analysis or heat map and decision support capabilities are used to get information from maritime data and investigate maritime traffic to be used with decision support and enlightening the development process with through data assumptions. So we will be able to see waterways density with desired filtering option and report generation capabilities. All these capabilities could be easily used with also existing data. Formal reporting features with statistical data integration to get any data as a report for formal users or to analyze data and improve efficiency. Another important feature is the easy sensor integration. So any sensor type known to the system could be easily added, edited, or deleted from the same screen with the availability to see system state and fault reports. Some of these screens I will show later. Also, VHF radio systems are integrated with our software, so all channel settings or recorded and replayed data could be used together for the need of the operators. Operator screen layout also is one of the hardest areas to please users. So Havelsan VTS gives the control to the user, so they could create any wanted dashboard design for as many screens wanted to be used. So the system could be used with one or n screens, vertical or horizontal, wide or ultra-wide. By this flexibility, even maps could be separated to multiple screens. For authorizations, Havelsan VTS uses a sophisticated control center to allow each function to be controlled thoroughly by complex rule permission relations. Sensors controlled screens could be reached also from site or centers with the same easy-to-use interface. So different radars, electro-optics, or radio direction finders will share similar interfaces and use together for safety. Here we can see, for example, a screen for our tracks in the screen, the main map screen. Here are two screens about the how we can draw areas, the coloring of areas, and how we get the alarms of it. Here for the replay, for example, you can use system tracks, radar tracks, radar plots, electro-optic videos, VHF radios, phones, notifications, sensor status, meteorological data, hydrological data, area info, route info, internal cameras, consoles, data to be replayed synchronously or separately. For the reason of control the permissions and attach them with the roles, here's a screen that you can do all this from here. And for the sensors and control them, there's several screens about it. These are just some screens for these reasons. Continuing to our presentation, Havelsan VTS can be tailored for user needs. It is built with the open software architecture principle, and it is structured so it could be scaled at any need. So adding a new feature or editing one will not affect the system at all. We try to keep everything customizable or ready for customization. Even fusion and correlation algorithms is customizable for user needs. Also, analog and digital radar video integration is one of the strong features of Havelsan VTS solution because it doesn't descale the radar and show small, hardly understandable images of videos, but it shows actual videos with mosaic effect. For external integration, Havelsan have a lot experience, so it is the same with VTS solution. All external data is exchanged to the system data before integration, before entering the system. Thus, any external data will be treated as internal ones. And this gives the ability to standardize the behavior of the system. Of course, Havelsan is ready to take part as your solution partner for efficient management of marine traffic management operations. Effective solutions that we are giving where vessel activity is congested and unique user experience with the operational sustainability provided by the assurance of Havelsan. We are giving turnkey system solutions, state-of-the-art application, customizable software for user need, cybersecurity solutions, holographic VTS, portable simulator, height adjustable operator console, IALA VTS recommendation compliant, and e-navigation compliance. Actually, you will be able to, for example, for holographic VTS, it's very interesting. You will be able to see your VTS with glasses in 3 dimensions. Vessels are going and coming all over the place. It's very interesting experience. All of you are invited. By the way, all of you are invited to Havelsan premises to live it here in Ankara, this experience. When we say e-navigation compliant, we mean a lot of things. A lot of tools, development, plans, and concepts. Some of these is done and some are still under developing actually. From our integration capabilities, our decision support applications to our architecture and visions, all main functions is done in consideration of e-navigation concept. So, last of all, I want to thank you for listening to a brief summary of a VTS solution, and I want to give the word for my colleagues Gözde Boztepe and Kerim Oğuzkara to show you some of our anomaly detection features.
Hi everyone, I'm Gözde Karataş. I'm currently working in Havelsan as a software developer. Now I'm going to talk about Havelsan anomaly detection solution. Maritime is preferred transportation. It is used for commercial purposes such as carrying cargo, transporting oil, chemicals, and personal voyages. Although maritime is the most used transportation, there is a debate about its safety. The concerns about maritime safety have increased both in civilian and military environments. Multiple platforms have expressed the need for auxiliary analytical tools to increase maritime safety and awareness of maritime situational awareness. European Maritime Safety Agency published the overview of maritime casualties and incidents reports annually. According to the 2020 report, there are 3,062 casualties and incidents, which 63 of them are very serious. Moreover, 21 ships are lost. Cargo ships are the most having accident vessel type, with over 40% in each casualties and incident type. In very serious and serious incident types, fishing vessels follows cargo ships with 30%. Passenger ships are the second rank with 30 and 18% in less serious and maritime incidents right after cargo ships. Next, please. According to the report, the en route phase is the least safe for all ship types. 43% of incidents occur while ships are in the en route phase. Therefore, knowing routes and being aware of actions on them is vital. Having speed and course information in routes allows us to detect anomalies. We may prevent some of incidents by detecting anomalies in the en route phase. Therefore, the route extraction is critical for anomaly detection. Next slide, please. Vessel route extraction and anomaly detection aims to assist operators by detecting anomalies that may be missed by operators with machine learning solution and statistical methods. First of all, we collect the track data and analyze them. Then we extract routes with machine learning techniques. Later, we detect anomalies with known route paths and notify operator against the anomalies. Next slide, please. Our main concern is anomaly detection to have safe navigation. For this purpose, we use historical track data to obtain existing routes. After analyzing the data, we extract routes from it with a newly developed algorithm. We use Python and machine learning libraries for the algorithm. The extracted routes are stored in the MongoDB database with the geospatial indexes. Finally, the routes are analyzed for speed and core statistics to detect anomalies. Next, please. We focused on some anomalies, for example, not following the expected route, meeting two or more vessels at the same point, heading towards a different port than destination port, not arriving at destination port in arrival time, not broadcasting in conformity with AIS data update frequency, and incompatibilities of speed and position information, having very low speed and unexplained high speed. Next slide, please. And Havelsan will continue to enhance its anomaly detection algorithms. Now my colleague Kerem Oğuzkara gives detail about it. Thank you.
Hi, my name is Oğuzkara. I am working as a software architect at Havelsan. I'd like to thank to Gözde for her speech. And let me start my part. So we'd like to provide a platform to VTS users, not only on which they can accomplish their day-to-day tasks, but also a platform where they can interpret data accumulating from their tasks. To do so, as my colleague mentioned, we are working on specific algorithms. We focus on highly compatible, horizontally and vertically scalable, fault-tolerant, big data analysis and AI infrastructure as well. Next, please. We take into consideration data that can come in from different sources and different shapes. To become more flexible, our platform can integrate with relational databases, non-relational databases, and streaming applications. Next, please. We'd like to have VTS users to reach meaningful information which is extracted from the collected data. To enable this, we focus on near real-time applications so that the information become available as soon as possible to be utilized in VTS users' decision-making process. We believe focusing on streaming applications instead of batch processing is key to achieve near real-time results. Next, please. We'd like to provide VTS users a big data analysis and AI platform that can integrate with any system, a platform that can scale according to users' data volume, a platform that does not fail, even if somehow fails, does not lose any information or interrupt execution when it is back online, a platform that can represent results in real time. To achieve this, we focus on some of the technologies like Python, Apache Kafka, Apache Flink, and Apache Spark. And this is basically what we are heading to achieve big data analysis and AI infrastructure. Now, I like to give back to the Mutaz for presentation.
Welcome to my presentation, VTS Unplugged. My name is Ahmet Borkostuk. I'm working on command control and defense systems as a software engineer and architect. I'm defining and designing architecture of our products, functional and data workflows. I'm also developing infrastructure automation and responsible for integrating open source products and platforms to our development and operation ecosystem. Today, I'm going to talk about how we managed our VTS products migration of monolithic architecture to containerized and distributed cloud-based architecture. we will see our roadmap to be cloud native, cloud agnostic, and be able to do edge computing in the future. In the beginning, our product was designed as a monolithic modular application. Before proceeding, I want to give a very basic definition of monolithic application. Monolithic architecture is a setup used for traditional server-side systems. Entire application has a single code base containing multiple modules, and modules are divided according to their functional or technical requirements. There are three main layers, as you see. The presentation layer on client side, business and data access layers on the server side. When we consider the server part, we can see that the system consists of a group of modules that are completely moving together and acting as a single process. The entire application is affected when it started, stored, and when it crashes. We need to intervene the entire application for any update or any bug fix. So after years of work, day by day, it became more cumbersome to our development and integration teams. These are some of the problems, as you can see, that we had in this architecture. The code base was too large and too complex to understand, and it was difficult to make changes fast and correctly. Because of the same reason, we were dealing with long build, test, and release cycles. We had to redeploy entire application on each update. Maintenance costs were an important part of the product budget. It was difficult to scale the application due to resource constraints. Another problem was reliability. A bug in any module, for example, a memory leak, could potentially bring down the entire application. At the end of this period, we realized that we had to change our perspective on our product's design and lifecycle. Next slide, please. All these problems that we experienced showed us that we need to redesign the product and told us that what we should pay attention more in the new design. Our motivation was delegating software and team responsibilities easily, separated build, test, and release cycles for each product functionality, improve maintainability and reduce the costs, fault tolerance, scaling each component of the application independently and improving the performance, to be able to monitor and analyze each part of the application separately. And the most important one is, I think, easy technology experimentation and integration. Next slide, please. So in the middle of 2019, we started to redesign our product with microservice architecture. Let's talk about a little bit what the microservice architecture is. Martin Fowler says that microservice architectural design is an approach to develop a single application as a group of small services, each running in its own process with isolated resources. Major advantage of breaking down monolithic application to smaller parts is each microservice can focus on one single business capability, which definitely provides better quality. With less development effort, a microservice can be built faster than a typical monolithic application. It's also easier and faster to manage changes. Failures are also less catastrophic than breakdowns in monolithic application. It is quicker and easier to identify, isolate, and fix the problems. We can quickly build a new version of faulty, problematic microservice without dealing with the operational waterfall that exists with a monolithic application. It's also easy to scale particular part of the microservices to overcome performance constraints. Next slide, please. In this slide, you can see some components of our open source ecosystem. While redesigning our product with microservice architecture, we built an open source ecosystem using various open source products to meet the requirements in the new architecture, such as infrastructure automation, cluster automation and orchestration, message queue clusters, cache and DB clusters, centralized logging and monitoring. I think it's easy to find open source tools which meet your needs, but the most important thing is to know how to connect them together and use them to provide best solution for the organization, for the product. Next slide, please. Okay, early 2020, after breaking down our monolithic application with microservice architectural design patterns and set up our open source ecosystem for the new environment, we started working on deployment strategies of our product. To make our microservices runnable, we packed each one in a separate container. So what's a container? Containerization is defined as a form of virtualization which applications are run in isolated user space called containers, all using the same shared resources. Container is basically a fully packaged and portable computing environment. In the figure, you can see our fully automated production model. There is a hyper-converged infrastructure running on physical servers. Over this virtualization infrastructure, we create virtual machines and virtual networks specific to the relevant production site. After that, we set up a container orchestration platform over this virtualization environment with the elements that we have created. On this orchestration platform, by using containers, we deploy all shared and application services. The shared services are gateways, message queues, database clusters, and the tools used for logging and monitoring. Then we get ready to deploy our microservices, which are also running on containers. Right now, we have about 80 virtual machines, 200 services, and nearly 600 containers on each production deployment. With this fully automated procedure, creating VMs and networks, deploying shared services and application services takes about an hour on each production site. With this fast and reproducible mechanism, it makes it easier for us to intervene quickly in the data center failures and on cluster recovery situations. Next slide, please. So, sorry. What are we doing now is we want our product to work on hybrid cloud, multi-cloud, and to be cloud agnostic. Hybrid cloud is a combination of private cloud with the use of public cloud services. The goal is to combine services and data from a variety of cloud models to create a unified and automated computing environment. To Today, like all applications, the purpose of our product is entirely related to how to process, distribute, and visualize the data. The most important thing is the data. When we think in this way, we realize that we need to classify sensitive data and public data separately, and we have to manage them separately. After defining the customer needs, we can distribute their public data on existing cloud vendors while storing their sensitive data in their private cloud. We can also different deployment models due to customer needs. If a customer does not want to run their own private cloud environment, we want to be able to run our entire application on any cloud provider. Cost management is another issue. To reduce the operating costs of our customers, we don't want to be dependent on any cloud provider. We want our shared services and application services to be portable. So we should easily switch to more affordable or high performance cloud provider anytime we want. And another subject is disaster recovery. We can use multi-cloud resources for disaster recovery to achieve resilience, availability, than in a single cloud infrastructure. By spreading the services and resources across multiple clouds, we can reduce the chance that a cloud vendor becomes single point of failure. Next slide, please. In the future, we want to add edge computing capability to our product. We are planning to distribute our clusters to remote areas near to devices. In this way, we can thread the radars, RDF antennas, security cameras, also IS devices, AIS devices, and the other ones as IoT devices. Okay, thank you for your attention. After this point, Mr. Mutazal Kabir is going to tell about some business advantages of VTS Cloud.
Thank you, Ahmet. By cloud solutions, users will be able to connect all your stakeholders under the same roof with the ability to easy access to the system, scalable usage without client console dependencies, swift deployment and updates, remote monitoring, mobile-ready service, centralized maintenance, and seamless stakeholder connectivity and integration. We talked a lot about our technologies, our roadmap, and because we really care and we really are trying to develop ourselves for the e-navigation concept. With e-navigation, actually, all type of softwares will be not usable, and new cloud solutions will be the only way to assure seamless usage for all stakeholders. Thank you all for listening to our presentation, and I want to give the word to Mrs. Nuket.
Mr. Al-Kabir, thank you very much for your comprehensive presentation. Thank you to all VTS team. I hope our guests found it very informative. Now we can move to Q&A part, where I'm sure you would be pleased to answer valuable questions of our participants. As far as I see from the chat panel, we have some questions.
Actually, please, everyone, you can enter your questions to the chat panel, and we will be happy to answer any one of them. I'm reading it. There is a question about anomaly detection. Does anomaly detection include study of small craft movement behaviors and create hotspots or heat map or for intelligence gathering? Actually, yes. Anomaly detection includes these type of data. You can, with anomaly detection, all the for anomaly detection, there will be the usage of heat maps and a lot of intelligence gathering, but for specific detail, Mrs. Gözde and Mr. Oğuz will give a better solution for it. I'm giving the word for them.
Thank you. Our work is actually based on AIS data. The device is mandatory for the ships that have more than 300 gross tonnage. Therefore, we find hotspots and create heat maps. Actually, our algorithm is based on the hotspots. However, we are currently working on it with integration of radar or other data sources to detect small chips. Thank you.
There's another question. Is the system capable of integrating with non-ICE transponders, satellites-based Blue Force and drones? Actually, our system have a main functionality named Octopus. We named it Octopus. It's a function module that will take any data, change it to our system data, and enter it into the system. So any user would be able to integrate the system with any data from satellite ICE or from other data like coastal surveillance data or any LRIT data, and gather it and enter it to the system to be used with inside data. There's another question. Can we perform our own data analytics and deep learning with available data? Example, using Python. Yes, we have the ability for it. If you have your data, we can enter it to our system, and you can analyze it with like our data. It will be just converted. There is a question about what other locations will Havelsan VTS be deployed. Havelsan VTS now being deployed to Istanbul and Çanakkale, two different places, and also will be deployed to Hopa, and it's now deployed there to be used in the Black Sea, and in near Bodrum. There will be another post that using Havelsan VTS, and we are planning on another deployment to other parts later. For the Python detail, the other question that can we perform our own data analytics and deep learning with available data, example using Python question, Mrs. Gözde and Mr. Oğuz would like to take to answer it also. 1 minute.
Yes, we can perform with our data to extract analytics. with deep learning techniques, with using the Python.
There is a question about the track performance of the VTS. The track performance, now we are testing it with more than 10,000 tracks simultaneously. And actually we are horizontally scalable, so we can handle a lot more, no problem with it. The only thing that we want is to open another cluster as told in cloud solution, add another machine to the cluster, and you will handle more, like 50,000 or more. Another question is, good morning, is it possible to use this tool offline? Yes, actually, in our last presentation, we talked about on-premise cloud. So an on-premise cloud solution, it could be used offline. And also you can deploy it to the open internet, and you can also use it online. No other questions?
Mr. Alkabir, I have a question, if you don't mind.
Yes, of course.
How Havelsan VTS reacts in case of disaster situations?
Actually, Havelsan VTS have a redundant and high available structure for disaster and contingency situations. So it is integrated between sites. So if one site goes, the other site will take the control, and the usage will continue. Our efforts now to make it work simultaneously. Mr. Ahmed can give us a brief about what is our planning for this situation. Mr. Ahmed, please.
As I mentioned in the presentation, we have a microservice architecture running on containers. So when a container or a microservice had a problem, when it shut down, it restarts automatically. And you can think that the system self-healing itself. And we have automated procedure for data center failures and disaster recovery situations. We can recreate our production site nearly an hour and reproduce the errors and find solutions to them. We are working on, as I said, multi-cloud resource, using multi-cloud resources for disaster recovery to achieve resilience and availability. I hope we are able to do that in the near future. Thank you.
Thank you. There is another question. Is your track and radar video data is proprietary or standard format that can be shared with third party, C2 or VTS? Actually, all our data we converted inside to our system data, so we can use it easily, and all data will be used in the same format. But for outside integration, for example, we have the ability to use open inter VTS exchange format, IVF. So it's a standard between all VTS. We can exchange any data, and also other radar and a standard data could be also given to other sources. There's another question about is Havelsan using own tracker or third-party tracker? Havelsan VTS using its own tracker. It could also use the third-party trackers, no problem actually with it, because we are using in our solution. We have 3 different type of radars that actually 4 different radars that integrated with the system, and some of them are digital, some of them are analog solutions. With the digital ones, we use their tracker, no problem. Actually, after we take the video, we convert it to our format, or we will only get the extracted tracks. For analog videos, we will take the video and get our tracks from it, extract our track from it. So there's no problem with it. Actually, we are using our tracker here, but with third parties, it's working as well. Another question about how it depends on specific sensors. No, the question is Havelsan VTS dependent on specific sensors? Actually, no, it's not dependent on any specific sensor. It will work with most standards or available sensors. The main thing here that to make the system know this sensor either by implementing an ICD or by implementing the API of it. For example, sensors like AS or VHF radios that have a standard, or radars with their standards, will be easily implemented to the system without any complex development. We'll be glad to answer all. Thank you very much. I think that there's no other questions here, and I'm giving the word back to Ms. Nuket.
Thank you very much for your replies and answers. Dear participants, if anyone has any further questions, please do send your questions to the email addresses contact info I posted to the chat box. We would be glad to answer all of your questions in a more detailed manner with relevant additional documents after this webinar. Looks like we have covered all the questions up to now. Oh no, we have a last question, I think. Type of Havelsan's tracker accepts input from the radar signal, analog and digital. One of our participants raised a question.
Actually, we have analog to digital converters. So either we can take the digital, or there's a card that change analog to digital signal. So analog to, there will be analog to digital convert, then using the data as digital. So yes, analog or digital data will be accepted by our tracker, because our tracker is not included with the card. It's a software that can run anywhere. So after the convert operation, it could be used.
Thank you very much. Again, I am sending my last announcement to raise your queries to my email. I will be glad to turn back to you. I think we came to the end of our presentations and our webinar. Thank you all to our valuable VTS team. And dear participants, may I thank you very much for your attention and active participation in today's webinar. We hope this webinar will be beyond your expectations and will give rise to fruitful relations between us. We hope to see you again next time. Wish you a healthy day.